Hello, welcome to Algebra 1. We're still working on the first learning target about functions. This is the third notes. We have more business about domain and range mostly today. Basically, we need to look at some new cases that weren't apparent in the last set of notes. So, here's the first example. We've got a little graph. We need to write the domain and range for that relation. So, first off, the domain. Now again, I drew on the axis the area where the domain goes, and we can see it goes from 0 to 9, so we make a set x such that 0 less than or equal to x less than or equal to 9. This is the same type of answer we had in the last set of notes. The range, we have a similar idea going on, and I drew on the y-axis where the graph is going. It starts down at 0 and goes up to 3. So the answer is y such that 0 less than or equal to y less than or equal to 3. Remember, when we're sandwiched between two numbers, it's always less than or equal to's on both sides. Okay, that's a reminder, similarly to the second notes. Let's move on. Here we have another example. This time, though, it's a little different. It appears to start in the same place, but on the right, there's an arrow indicating it goes on forever. So for the domain, again along the x-axis, I showed how it starts at 0, but this time it doesn't stop anywhere. There's an arrow on the end. This means all the numbers above 0 are good numbers for the domain. So it's x such that x is greater than or equal to 0. Starting at 0, all the numbers 0 and above. The range, on the y-axis, show here where the y-axis is covered by the graph. Again, there's an arrow on the end because the graph is still rising, so it's still going up in addition to still going over. Here for the y's, it's also starting at 0 and going up forever, so it's y such that y is greater than or equal to 0. As always, we need to work on remembering our braces. And here we have the new kind of example where it starts at a certain number and goes forever. So here, this one does turn into a greater than or equal to because it starts and goes forever. Next example, just like before, but now they're open dots on the end, we call them. They look hollow. What that means is the graph goes right up to the point, but it does not quite touch the point. So, for example, for the domain, and what I'll show on the graph is the same, it starts near 0 and goes until near 9. So it's all the numbers in between 0 and 9, except it does not include 0 or 9, and that is because of the open dots. So it's x such that 0 less than x less than 9. Notice there's no or equal to this time, because they're open dots. Range, same kind of basic idea. Starting at 0, going down to -3, but again because of the open dots, y such that -3 less than y less than 0. All the numbers between -3 and 0, but not actually including -3 or 0. Again, this is because of the open dots. So anytime you see something with an open dot, you might want to come back and look at this example 3. Alright, next one, example 4. Here the graph does a double mid swoopity-doop, but it goes forever on both ends with the arrows. So, for the domain, I'll show on the x-axis how it goes forever both ways with arrows both ways. So this is all the numbers. Now that is written a couple of ways. You could write the words all real numbers in a braces. Kind of annoying to write, so there's a cool way of writing it instead, which is an R with a double back. So it's an R, but there's two lines down the backside, and no braces. It's a super fast way of writing all real numbers. Now, for the range, Same kind of idea. It goes up and down with arrows because it is going up forever on the right and going down forever on the left. So in fact, the answer is still all real numbers because the range goes up forever and down forever. You can write it inside a set, or you can write that double back R business. Anytime the answer is all real numbers, if you want to learn the lingo and be cool, you can write the double back R instead. Okay, example 5. One more example here on domain and range. We've got some dots. So the domain is just the spots where the dots are on the x-axis. So, excuse me, I misspoke. The spots on the x-axis where the dots are. So, 1, 3, 8, and 9. This is exactly the same as what we saw last class, putting it in here as a reminder, as a little bit of contrast with what we had before. Range, same idea, but this time on the y-axis, -5, 0, and 7. Alright, this example is not new stuff. If you totally understood exactly what was going on last class, this one should not have surprised you, except maybe, what is it doing here? It's just a reminder from before. Now we're moving on to plotting points. You've plotted points before. You've made in and out tables or x and y tables. We're going to just start to get back in that habit. Put it all together. Equation, table, graph. So, get your calculators ready. Here we go. So this first table, I picked some x's for you for the line y equals 3x minus 2. Here I'm showing substituting the x value into the equation and getting the value. The first point is -3, -11. My graph only goes down to -10, so not really possible to graph it. You could try to graph it just near the grid if you want, but not necessary. Next point is when x is -1, so -1 goes in for x. The answer is -5, -1, -5. Boom, there's your dot. The next one, 0 for x. So you get the point 0, -2. Boom, dot. The next one, 2 for x. The y is 4. You get the point 2, 4. Boom, dot. The next one, 4 for x. You get 10 for the y, so 4, 10. Boom, dot. Now, I made a table with these x values, but those were just sample x values. The truth is, any number would work for x, and that would make a y, which makes any point on that line. So, connect them with a straight edge, please. Draw arrows on both ends to show it goes forever. That's your graph. Now domain, well, it goes forever on the x's, so it's all real numbers. Or, if you're feeling spunky, just the R. Okay, for the range, you can see it goes forever up and down on the y's. So the answer is all real numbers. Or, again, if you're feeling spunky, that R. Okay, one more example. This time the equation's a little more interesting, but you get to also choose your own x's. So, here we go. First number to choose almost always would be 0. 0 is the easiest number to work with. And when the math teacher makes the problems, the points tend to be on the graph. So, 0, 3, boom, dot. Next one is 1, -1 squared plus 3 makes the point 1, 2. I really recommend you get in the habit of using your calculator correctly. In fact, it would be wise for you to follow along, especially on this one, to make sure you can get your calculator to make the same y's that I'm getting from mine. Next one's 2. So -2 squared plus 3, -1, boom, dot. Next one's 3. You get negative 6. Boom, dot. Now those are getting low. I'm going to go to negative land. Negative 1 for your next x. You get 2. So the point negative 1 comma 2. Huh? That's not a line. Okay, well, maybe one more point. This looks a little strange. We'll do negative 2 also. You get negative 2. Excuse me, I miswrote this. Right here. Should be negative 1. Negative 2, negative 1 is your dot. Boom, dot. Okay. Now, you can see this is definitely not a straight line. You can connect it. It goes forever. The numbers just get kind of crazy small, negative. You could add more if you were feeling spunky about it. It goes forever. For the domain, well, it seems to cover those x's, but it goes forever with the arrows on the end. So the answer is all real numbers again. But hopefully you're starting to believe me that drawing that R is a little bit easier. Next one, the range. It starts up at 3 and goes down. Notice this one actually starts at 3 and goes down. So it's not all real numbers, it's just the numbers less than or equal to 3. Y such that y is less than or equal to 3. Okay, definitely come see me if you're having trouble getting the correct y's out of your calculator. Bring me your calculator. I'll show you some tips. It's a solvable problem, but I need to talk to you about it. Look at these domains and ranges. Please look at the differences between the examples. They were made differently slightly on purpose. See what you can do to match up. And as always, please let me know if you have any questions, and I look forward to seeing you in class. Thank you for watching.